The James Webb Space Telescope has obtained a stunning image of Westerlund 1, our galaxy's largest supercluster. Located 12,000 light-years from Earth, the cluster is a dense cluster of young stars that are thousands of times more massive than the Sun. While superclusters were more common in the Milky Way billions of years ago, they are extremely rare today. The stars in Westerlund 1 range from 50,000 to 100,000 times the mass of the Sun and are concentrated in an area just 6 light-years across. The yellow hypergiants in this cluster are about 1 million times brighter than the Sun and formed about 3.5 to 5 million years ago. Westerlund 1 provides scientists with important information about the life cycles of massive stars and supernova explosions. Scientists predict that the cluster will produce about 1,500 supernova explosions in the next 40 million years. This image, taken using the Webb telescope's NIRCam camera, is part of research on Westerlund 1 and Westerlund 2, which is being used to learn more about star formation and evolution. The James Webb Space Telescope continues to unravel the mysteries of the deep universe. Finally, the telescope, focused on Westerlund 1, the Milky Way's largest supercluster of stars, is providing striking new information about this cosmic laboratory. Located about 12,000 light-years from Earth, Westerlund 1 is home to massive stars with masses tens of thousands of times that of the Sun. These massive stars are packed into a space just a few light-years across and have become one of the brightest regions in our galaxy. The formation of Westerlund may first be closely related to the intense star formation processes of the early Milky Way. Formed by the collapse of a large molecular cloud, the cluster evolved over time due to the gravitational interactions of the stars within it. The distribution and motion of the stars in the cluster provide important clues about how these interactions occurred in the past. The future of Westerlund 1 is quite dynamic. The most massive stars in the cluster will quickly burn through their fuel and die in supernova explosions, sending shock waves and heavy elements into the surroundings. These explosions could trigger the formation of new generations of stars and fundamentally change the structure of the cluster. The Webb telescope's infrared observation capabilities are ideal for studying dusty and gaseous regions like Westerlund 1. The telescope's high-resolution images allow for detailed studies of the stars within the cluster, providing more precise information about their chemical composition, temperature, and motion. It also helps us better understand the structure of the gas and dust clouds surrounding the cluster and their effects on star formation processes. Studying superclusters like Westerlund 1 provides important information not only about the life cycles of stars, but also about broader issues such as the evolution of galaxies, the chemical composition of the universe, and even dark matter. Because these clusters are where the most violent events in the universe occur, they also hold important clues about conditions in the early universe. In the future, with more advanced telescopes and observation techniques, we will be able to obtain more detailed information about superclusters of stars like Westerlund 1. In particular, space-based gamma-ray telescopes and neutrino detectors will allow us to examine the violent events taking place in these clusters more closely. In addition, thanks to developing computer simulations, the formation and evolution of clusters like Westerlund 1 will be better understood. In short, Westerlund 1 is one of the most mysterious and energetic objects in the universe. Thanks to the James Webb Space Telescope, we have access to more detailed information about this cosmic laboratory than ever before. The study of Westerlund 1 provides us with new information about the birth, life and death of stars, while also helping us find answers to important questions about the general structure and evolution of the universe.